Ready, so in this video I'm going to be talking about what is ionization energy. So in simple terms, the basic definition of ionization energy, and the only definition you need basically, is ionization energy is the energy required in order to take away an electron from an atom that it's in. So if you have, let's say this is the nucleus, you have a shell right here, and this is going to be our valence shell, the last shell. Okay, we have a couple of valence electrons here, and it's basically the energy required to take away an electron. And then the second electron would be the second ionization energy is the energy required to take away the second electron. So after you took away this electron, the second ionization energy would be the energy required to move the second. Third ionization energy would be required to move the third, and so on. And in general terms, usually the trend is, so basically the more okay, so to begin with, let's say you take away the first electron, the second electron you take away usually requires more energy, the third requires more and more, the fourth requires even more energy. But sometimes what makes a difference is the change in the energy that was required to move the following electrons. So let's say the first one, the first ionization energy, which is the ionization energy required to move the first electron, was, let's put it in simple terms, let's say 2 joules of energy. And let's say the second one was needed 4 joules. This one was 15 joules, and this one was 17 joules. So you see right here, okay, there's a basic trend that it's increasing, okay? The first electron to take required that much, 2. The second one required more, the third one more, the fourth one more, but the change in sometimes differs. So right here, all right, so if I graph this, okay, this is the energy right here, put in joules, and this is which electron we're taking. Okay, so the first electron required 2 joules. Second one required how much? 4 joules. The third one required 15 joules, and the fourth one required 16. So you see this spike right here, okay, this spike. And I'm going to talk about like the explanation of the spike, why it happened. So, okay, we see the basic trend that it keeps on increasing, but by how much it's increasing is what we're going to be talking about right now in detail. So the electron that requires the most energy, okay, to take away from an atom is a core electron. So let's say we are looking at some all right, some atom that has the electron configuration, okay, of 2s squared, 2p, 2p2, right? Okay, obviously our outermost shell is the second shell, okay, because we have a maximum coefficient of 2. So if we draw this out, so we have our nucleus right here, and then our first shell, and then our second shell. So the inner shell has 1, 2. The second one could hold a maximum of 6, but in this case we only have 4. So that's 1, 2, and 3, 4. So what we see here, the orbitals, these are important. We take away the first electron. So if you draw the electron configuration, not write it out. So draw it. Let's look at the last one. We have 2p, and any p orbital has, okay, a maximum slot of 3, which each one holds 2 electrons. All right, so we have 1 and 2. To take away the first valence electron, all right, it requires, okay, some amount of energy. Let's say 5 joules. To take away the second p orbital, all right, it's not going to require that much. Say about 7 joules, but it's still more than the first one. All right, then we move on to the 2s. Okay, 2s, all right, it's filled. And it requires, you know what, let me draw this out much nicer. So we have right here the 1s, the 2s, and this is the 2p. Okay, this is the 2p. We said it only had 1, 2. The 1s was completely filled, 2s is completely filled. Okay, this is the first electron. We're going to take that away. It's not going to require that much, 5 joules. Second one, we said about 7 joules, but it's increasing, all right? And then, okay, this is 2s, this is 1s. And then we're going to take away the third electron, all right? It's going to require a bit amount of energy more than the change in that we had here, because we're ruining a full orbital, and ruining a full orbital requires a lot of energy to ruin. So we're going to see quite a bit of a spike. So let's say now we have about 12 joules, okay, required to move that one. And then let's say we want to remove this one. All right, it's not going to require that much of a spike, but it's still going to be more than the previous one. Let's say 14 joules. Okay, and then finally we're out of the valence shell. We're done with the valence electrons. Now we're moving to the core electrons. Okay, that's an area you don't want to mess up with. You don't want to mess with. So now we're moving to the innermost shell, or a core shell, all right? And we're gonna take away from that. We're gonna see a huge spike. Let's say 29 or 28 joules required, and you see that's a huge spike. That spike that we saw earlier on is because we took away a core electron. After taking away all the valence electrons, we're moving to now take away from a core shell. That's going to require lots of energy. And so that's basically the general intuition of how this works, why it works. And let me give you guys the, what is it? No, not this, not that. Okay, so all right, this is not going to work. I don't know how to use this. But so let's say we have right here, I'm going to zoom in. Okay, guess not. But the basic trend, so I'm going to draw a little periodic table right here. All right. So the basic trend of how this works is that the more you move up and to the right, ionization energy increases. So you could draw like a diagonal uh, denoting the general trend of ionization energy. And this is a trend of the periodic table. In other words, a specific periodic trend. In this case, it's ionization energy.